My friends, before we dive headfirst into the nuts and bolts of networking, we just need to ask ourselves one question. What exactly is networking? And I don't mean to start you off with Zen here. You're not going to have any existentialist questions on your exam, anything like that. But the key is here, why are we doing all this stuff in the first place? And how did we get started? I'm not going to give you a big long-winded history lesson here, but I'm going to give you a little bit of one because for those of you who weren't there, what I'll describe first will be absolutely laughable, but that's just a generational thing. It's just a time thing. And those of you who have been networking for a while, especially back to the beginnings of networking in schools, that kind of thing, wow, I mean, the first time that we set up a network where multiple users could print to one printer. Oh, it really was. I mean, it was like you just wanted to, dance around the room and throw rose petals in the air. You just couldn't believe it. It's like we can send 10 print jobs from 10 different people to one printer. And it really was amazing. The only problem is, human nature creeps in then. And anytime you give someone something, they're usually grateful for it at first, and then they say, what else can I get? And that's really what happened with networking, because things got just a little more complicated than sending print jobs to a printer. It seemed like everybody wanted something else all of a sudden. Hey, wouldn't it be great if we could send each other files? Wouldn't that be spectacular? Wouldn't it be great if we could set up the network so that all of our data was in one place and we could just back it up right there? Of course, then you had e-commerce when e-commerce came along. And, hey, can we set up our e-commerce servers so that only certain people can have access to them, which is a really good policy for your e-commerce servers. Then, of course, voice came along, and some networks weren't ready for it when it came along, speaking from experience. But the key is, people wanted voice conferencing to their network. And then, now we've come to the point of, hey, wouldn't it be great if we could see a person's face while they host an online meeting for the company or teach a class or anything like that? Well, when the first computer networks were put together, and for a while after that, services we use today without a second thought, and I mentioned GoToMeeting just because I like the product, not because they're paying me for it, but if they want to send a check, go right ahead. All those video voice conference tools, they were fantasies. If I had told someone 10 years ago or 15 years ago, one day we'll have these meetings online and you're going to see the person's face if they want to put it up there and then everybody can collaborate. I mean, wow, what a fairy tale that was. Now, as we've gotten more and more great network services, our networks, of course, have grown and grown and grown in order to handle those services and make them available to our end users. Networks that were fine 10 years ago, 15 years ago, network devices that would have served us fine at the time, I mean, again, you can even begin to use some of them today. Now, we also have to secure our networks. And you and I know, even at the PC level, how that can complicate things. Hey, I can't open this attachment, which, of course, many times you shouldn't open that attachment. I didn't get an email because it got filtered, that kind of thing. And, of course, firewalls can stop you from opening applications on your own PC until you manually tell the firewall, hey, it's okay for us to open this. So the tools that we use to do that, secure the networks, can also complicate things. And boy, look at all of these different servers that we've got to deal with today. Of course, we have our PC. We have mini PCs, of course. Then we'll have certificate servers. Then we'll have e-commerce servers. And it's very important to keep a money bag right next to your e-commerce server, like in this drawing, so you know what that is. That's what I do with mine. Then, of course, we've got all our print servers. We've got firewalls, database servers, mail servers, proxy servers, file servers, web servers. We've got all kinds of networking devices that we have to allow to talk to the right people and not talk to other groups of people. One thing I want to mention here, I know that some people taking this course will be very new to networking, and I want to welcome you aboard. But I know from experience that the thought of putting all this stuff together for the first time, it can be really intimidating. And people don't like to admit that. It makes you look bad. But, it can be. And you just walk in a network room that's already been put together, and you got all these lights going everywhere and all these different devices. It's just like, wow, what are we doing here? So the key to success in this field, as far as I'm concerned, and I've seen it work for thousands of people, and to keep calm when your studies intimidate you, you're always going back to the fundamentals in this business. Success with networking, and I don't care if it's on a computer-based exam or in a real-world server room, It's all about knowing and applying the fundamentals. And there's a major reason I mentioned this at this point in the course. The material that you're about to study, networking models, TCP and UDP operation, networking fundamentals, this is the most important part of your networking studies. It's what I always tell people when you look at a pyramid. Where do your eyes go? Your eyes tend to go to the peak. You're looking at the top of the pyramid. But the top of that pyramid would not be possible without the foundation. It's true of any building. You look at a 100-story building, where do you tend to look? You tend to look at the top of the building. But that top story isn't possible without all the stories underneath of it. And that's just the way your study should proceed. This is actually the most important study you'll ever do. I don't care if you go after the CCNP, the CCIE, beyond that. I don't care what you do, what you're doing right now. This is the most important study that you'll ever do, because this makes it possible for you to understand the more advanced concepts later on. The reason I mention this, one night when you're tired, and maybe more than one night when you're tired, and you're hitting your studies hard, and like I said, you've got a job going on, you got family going on, you got God knows what else going on, and it's easy to look at some of this stuff, especially the OSI model, that kind of thing. Maybe not the most exciting stuff. It's not as exciting as actually working on the equipment. And you think to yourself, do I really need to know this? And I'm telling you this because I was in your shoes. I was at that desk at the local library studying a Novell networking book with all these confusing networking models. It's like, do I really need to know this to learn Novell NetWare? And my point to you is, yeah, you really need to know this material, and you'll see why, because it really does help you in the real world. So just a little extra dad lecture there in case you ever get in that particular mood. And let's go ahead and hit that networking model, because again, this isn't something just to memorize for the exam and then forget about it. We're at a junior high school, and even some high school classes. You learn things, you pass the exam, you forget them, and then a year later you don't remember any of it. It's because you didn't use it. But you're going to continually use this. The two ways that I've always learned or always used the OSI model, one is for real-world troubleshooting. And we're going to go back to that throughout the course, not just the actual troubleshooting, but some procedures for it, because that's really what the average, if there is an average network admin job, that's what we're doing most of the time. That's what we're doing on the exams, and it's also what we're doing in the real world. Most of us do not get to go to a job where every day we're building something. We're building a new network or adding something on. What are we doing? We're troubleshooting, and we have to know how, and there is a process to that. This also helps us break networking down into pieces that's easier to learn, because if you look at any of this stuff as a whole, if you just pick up, one of those 1,000-page networking books off the bookshelf, and you just look at that as a whole, you just go, oh man. The books aren't nearly as thick as they were when I started. I mean, seriously, you'd pull a muscle pulling one of those things off the bookshelf, and you just look at it, you get intimidated. Or just think, oh man, just look, your brain just says, look at all this stuff. But if you take it one piece at a time and just keep building, you'll be fine. And that's where the OSI model actually helps you learn networking. Speaking of that, let's get to the OSI model, and I'll pull it all up in their screen for you. We start at layer 1 at the bottom layer, physical data link, network transport session presentation application. I'm not bad-mouthing anybody who uses an acronym at first to remember the order of these layers, but really as you use them, as you study them, and as you proceed in your career, you're not going to need that. So if you need some kind of acronym to remember, PDN, TSPA, from 1 to 7, that's fine, but don't use it in a job interview. I will tell you that. Do not go in there and start reciting some 7-word catchphrase to remember the OSI model. It's something you should know. Speaking of what you should know about it, let's look at the application layer to begin with. Did I get cut to my next screen? It did. Now, that's not everything you need to know for the exam on the screen right there, that one diagram, but it's a real start, because that is the application layer in a nutshell. It is where our end users interact with the network. But the application layer also performs some important behind-the-scene tasks. It makes sure that the remote communications partner is available to begin with. It takes 2 to tango, and it takes 2 to network. You can't network by yourself. It also ensures that both ends of the communication agree on a pile of rules, which sounds a lot better if you say myriad of rules, including data integrity, privacy, and error recovery or lack of same. And we'll discuss that. That's going to pop up throughout the course as well, that error recovery. We'll talk about it shortly here in this part as well. The presentation layer, short and sweet. This layer answers one basic question, and that question is, how should this data be presented? And we don't mean, on the screen. Yes, we would like to see it on the screen if we open something up in Word or any other word processing app. Now, this doesn't happen as often as it used to, because the word processing apps have come a long way. But if you used to open a PDF with a Word app, say Microsoft Word, for example, you usually just got pages and pages of garbage characters, just ASCII characters. Well, that's a presentation layer issue. Doesn't happen as often as it used to. But another important thing that does happen at the presentation layer is encryption. And obviously, network security is a huge topic in today's world, and it's not going anywhere anytime soon. So you're going to hear a lot about encryption in this and future courses as well. Now, the session layer, this is the manager of the overall data transfer process. It handles the creation, maintenance, and teardown of the session, the communications channel, that the two parties are using. Because we're not going to have a pre-made session between every PC in your company or in your network or in the world. It has to be built and then maintained during data transfer, and then when the data transfer is done, it's going to be torn down. Now, the transport layer, the main purpose of the transport layer is to establish a logical end-to-end connection between two systems. But that is not the only thing going on here. There's so much going on here with the Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP, that I've given them their own section in the course. I'm just mentioning them here because, as I said, this is an overview. I know I'm saying often we're going to do this more later in the course, but I didn't want to go to each OSI layer and then say, okay, let's talk about TCP, UDP for half an hour here. I'd rather save that and just do an overview here. But in all seriousness, these two protocols are so important, and their operation is so important, that it could be worth 100 points on your exam. So we will be hitting a lot of detail there. Now, going back to the overall OSI model, those top four layers, you and I in our everyday job as network admins, we could go weeks, months, years without even thinking about them. Most of what we do on the job is at the bottom three layers, and especially the network layer. Because you and I are going to spend a lot of time at the network layer in this course. We're going to be doing a lot of Cisco router labs. And the layer processes, the network layer processes, really answer two basic questions for us. What valid paths exist from here to whatever destination we want to go to, point B? And of those paths, if we're fortunate enough to have more than one valid loop-free path, which one is the best? Well, boy, that seems simple, right? I mean, nothing to it. Class is now dismissed. It's not quite that easy. I think it's going to be a little more complicated than that on your exam, and I can guarantee it's going to get more complicated than that in the real world. Right now, the only thing I really want to mention about routing is the IP addresses you're familiar with, 172.12.123.1, looks something like that. They're used at the routing layer. There's another important address that we use in our networks, and that one runs at one layer down, and that's the data link layer. I'm going to introduce you to something in networking here that can get a little bit annoying. It's not this first set of terms because our switches run at this layer, the Cisco switches we're going to be running hours of labs on, but these protocols do as well. Ethernet, which you've probably heard of, HDLC, PPP, and frame relay, which you might not have heard of, but we will definitely fix that in this course. Now here's the annoying part. Sometimes in networking we have more than one name for the same thing, and it's no big deal. We usually don't have 7 names for the same thing. We're actually down to 5, I think, for the MAC address. We used to actually have 7 different names for this. But these are terms you should be familiar with. They're all referring to a layer 2 address. And one of the names is layer 2 address. Okay, that's intuitive enough. Hardware address, BIA, which stands for burned in address, and then a physical address. Well, where in the world are those names coming from? Well, the key here is that with that hardware, let me go back to the previous screen actually. I think I cut something off there. There we go. Now, the first name again makes perfect sense, but we're at layer 2, it makes perfect sense to call it a layer 2 address. Where are those other names coming from? Well, this address is actually burned into the hardware. It's actually burned into your network interface card. So you can see where the hardware name comes from, and you can see burned in. You'll actually see Cisco routers refer to these addresses as BIA addresses or BIAs. But watch that last one, it's a little misleading. We sometimes call the MAC address the physical address because it physically exists on the card, not because it runs at the physical layer of the OSI model, because it doesn't. So just watch that. The physical address does not run at the physical layer of the OSI model. It runs at the data link layer. Again, the primary device we're going to work with at layer 2 is a switch, which we will spend hours with very shortly. Before we stop this particular video, I want to introduce you to a couple of terms that sound like they do the same thing, but there's a difference and we need to be very clear on it. Error detection versus error correction. Remember, detecting something doesn't mean you're correcting it. And this is a very important nit that we are picking here. I know it kind of sounds like, I'm really slicing the bologna thin there and really, taking two terms that mean the same thing. They don't mean the same thing. And when we come back and we hit the next video, we'll talk about the frame check sequence and a little bit about the physical layer of the OSI model before we move on. So I'll see you there.